Yeah, hi everyone. I'm always very happy when I'm in a room where there is a light, because many lectures are actually in dark rooms, although my slides are in dark mode. I'm sure that there is many people in this room who have experienced the situation when they had to spend much time on their laptop, on configuring the laptop or environment before they can actually start doing the work. We are facing this issue at a much bigger scale. We at the university in the Czech Republic, we teach courses on distributed systems and machine learning. And we have around 200 students who we have to deal with different environments, provide different environments, and so that they can actually complete the assignments they need to do in the courses. And this was a big pain, so we decided that we want to build something which will solve this issue, and we built a platform that we call KHL. So you can think of a KHL as GitHub Codespaces, but it's all running Kubernetes, and it's yours. And you have workspaces that are provisioned on demand directly in your Kubernetes cluster. So we basically do two things. So not only we solve the issue that we had with much time we had to spend on configuring the environments for the students, but we also build a platform that we use for the teaching at the same time. So we show the students how we can build a platform from scratch using a proper microservice architecture, fully integrated into the Kubernetes ecosystem projects. And this is basically the best practice that we put a lot of knowledge into it that we gained over the years. So let me just show you the architecture, which is one of the view on the architecture, how it looks like. So in the core, we have SSH proxy, which is a component that talks to the client using standard SSH protocol. So this was one of the requirements that we have defined at the beginning, that we didn't want the client to install third-party tools. We just want them to use the SSH protocol, because there is a lot of tooling like IDE with remote SSH plugins that they can use to connect to the system. So the students or developers, they don't even need any Kubernetes access. They just need SSH, they just need keys they already have registered in the system, and they can connect and use and provision the workspace on demand. So there is a number of services. So these are the core services that you can find in the platform. So the first is the identity, which we can use to onboard users from the external identity providers. So for example, the users already have, their accounts in GitHub or GitLab, and we can onboard them from the external system. Again, the user just uses the key that has registered in the GitHub and use the key to authenticate. So the identity authenticates the user using the key. The next thing that we just put into the platform is the authorization engine. So from the SSH protocol perspective, you have a number of channels that are being created during the connection, like for example, the session and shell channel. There is many channel requests that the client sends, like for example, agent forwarding or pseudo terminal request or environment variable requests. And what we do, we map those features of the SSH protocol to the actions, and then we define policy for which we use the open policy agent and the enforcement engine provided by the OPA to actually verify and define whether the user can have access to that specific feature of the SSH protocol. And we do this across all the platforms, so this is also possible to do at the API service level that is not shown in this picture. So the next thing is that there is a provisioner that checks whether the workspace already exists, and if it doesn't exist, it provisions the workspace on the fly using the Kubernetes API. And what it does is basically it installs the Helm chart that is embedded in the provisioner service and creates basically the workspace using the predefined Helm chart that you can then actually access the Kubernetes cluster, and you can see those Helm charts being installed by the provisioner. You can even interact with them at the Kubernetes API level. And then once the service is running, the workspace is running, we have the workspace that is started. And for that, we have built the KHL daemon, which is a lightweight process that is running as the process number 1 in the container in the pod. and that exposes the gRPC interface that the SSH proxy then transforms all the SSH communication over to the daemon process using the gRPC interface. So the client, the user, can access the workspace using SSH, but there is no SSH daemon running inside the workspace. So there is only running KHL daemon, which is a lightweight process with the gRPC interface that that provides that functionality. And we can use exactly the same gRPC API for the API service access. So we have API server, which is not in this picture, but we can actually access the same functionality provided by the gRPC API from the web console as well. So this is just the example what it means for the user to connect. So the first thing that the user needs is the username, right? But we need to be able to define not only the username, but also the workspace where the user wants to connect to. So we divide the username part of the connection string to two parts. So one is the username, and the second one is the definition of the workspace that the user wants to connect. So if the user is onboarded via GitHub, then you can specify the repository that you want to build your workspace on. And what the system does is that it reads the information about the predefined workspace definition, which we call the workspace blueprint, from the repository, and provisions that workspace using that definition. It takes around 6 seconds. So all the process that I just went through before in the slide, in the architecture slide, it takes around six seconds. And then what is also happening is that there are init scripts that are run as part of the initialization process. So you can define the, for example, git cloning. You can define the additional, setup scripts that you need to have that you would like to, run in the in your workspace before you can actually start working with it. So this is just the example how you can access the workspace using SSH. You don't need anything on the client side, just need SSH protocol capable client, or for example, SSH CLI, or you can use the VS Code with remote plugin. It works exactly the same. And you don't feel, from your perspective, when you connect to the workspace, you don't feel that you are actually running your workload in a pod in the Kubernetes. You just access it like this. So there is also an option to use the web console. In here you see just a screenshot of a web console where you can actually connect to the workspace using the terminal. We also have the capability to upload and download files. So there is a file browser that again connects to the workspace using the KHLD gRPC API that allows to actually, that implements the SFTP protocol, and you can use it like this. So yeah, so we have, as I said, we have around 200 students. Those students are attending two kinds of courses. So one is the machine learning labs, which are CPU-bound courses where they really use a lot of CPU during the time when they need to complete the assignment. And then we have system labs courses, which is more like IO-bound tasks. So this is not really CPU intensive, but something they're running in the workload, and they, like a reverse proxy, wait for something to happen on the back end. So it was running very well. We have monitoring in place. So this is just a snapshot of monitoring where we have a course, like a lab running during the time. So there could have been like maybe 20 or 30 students connected to the system at the same time, and they all shared the same infrastructure and all the resources that the Kubernetes cluster provided to them. So the cluster was quite big. We had 1 terabyte memory across 3 nodes and around 260 CPU cores. So obviously when they run the machine learning course, they required more CPU. But again, we were able to limit the CPU usage by resource limits that you can also define for the workspaces. So unfortunately, I will only have 10 minutes for this talk. But if you have more time, if you have more questions or any question, then please talk to me. I'll be more than happy to give you the demo, and you can also check it out on our site. So it's agpl license that you can use those components at the GitHub repository, or we have a website that you can check out the details of what this platform is about. It's available. Thank you. I don't know whether there are any time for the questions or whatever. Okay, yeah, sorry, so no questions.